So here's the loser class from lab 3, and I'll just see if I can point out some of the common things about it. It looks like a normal class, except at the top it says implements comparable, so that's you can sort it waving the red flag, and someplace there will also be a compare to inside the class that corresponds to implements comparable. There's the setter for current weight, and there's the anorexic option that just rejects them if they try to set the weight too low. And at this point, you should be getting used to the getters and setters and all of that sort of stuff. So the important pieces in here are really what happens with the equals and the compare to. And so the easiest way to think of equals is to think of, if I were going to go to try to find another one of these things, what would I expect it to be, right? So if I were interested in finding my car on the street, or similar to my car, what would I expect it to be? Well, it would be a Toyota Echo something or other, right? And so you worry about the important things of the car, and I wouldn't be going and saying, oh, okay, if I see a Toyota Echo on the street and it doesn't have the right lug nuts on it, then I don't think that's my car. That's getting way too specific, right? So you're trying to find the thing that's the most reasonable match. So in this case, for losers, if there's one Fred on the show, that's probably the only Fred, and so it's good enough to just work on their name. Okay? The thing that you don't want to put in there is Fred's current weight. Because if you put Fred's current weight in there, you're saying, I think the Fred that is 200 pounds today is somehow different than the Fred that's 198 pounds tomorrow. Okay? That's too specific, so the only things that you normally put in equals are the things that are not going to change for the object. So in this case, just by name. And after a while, when you start to read those, when you see equals, you just go, oh, it matches by, and you just look for the names of the fields, and you don't worry about the format. Compare to is the one that's used for putting things in order. And so in this case, since I have the get weight difference function already, I just reused it to get the values of the difference between the two people. And if the weight difference was the same, then I called compare to for the name. Okay. This was the driver I wrote, sort of half expecting that people would end up with the same thing. This corresponds mostly to what I was asking for in the lab write-up. I pulled a little trick here, in case you've never seen that before. Here's an array of names that are just strings. And I turned around and initialized my driver list by going through and adding a new loser with the name of the person. So I end up with all those 4 different people as new losers, all with a weight of 170. It was just a cheap little trick for getting a bunch of names in. But it does show you that you can run a for each on a string array. That works just fine. The idea of changing weights for people, the only way that you can change weights if you're not keeping track of them. So notice I didn't use variables to keep track of them, so they're sitting on a list someplace. Now I have to get them off the list. The only way I can get them off the list is to run a for each to go through every single person on the list. That's going to retrieve that person, find out what their current weight is, and then put their current weight back minus 2. Okay? So that's sort of what I was looking for there. And it's this idea that it's a 2-stage process. You have to get the person's weight, and then you have to turn around and set it back in order to get it to change. Okay? There's no, some people tried to add a function in there to say, oh, okay, I'm going to go change person's weight by 2. Okay? But in general, you should only work with what you've got for the class. So the only methods we had were either get it or set it, not change its weight by some amount. Okay? So that's the long way of having to do that. And then I printed them all out afterwards to see what their weight loss was. Here's this idea of going and retrieving some people from the list. So in order to retrieve them, you're going to search for them. So I searched for them by an index of, there's my fake loser. I didn't bother putting them into a variable because I didn't need to keep the variable around. And you can tell that it's not a real user because it doesn't have any weight. Okay? So there's the idea of making use of the fact that it's only going to match by name. A lot of people put an actual value in there, but that just hides the fact that it's not a real one. Okay? So putting the 0 in there just says I'm basically going to use it for matching, and it also says the name is what I expect equals to match by. So that will retrieve the Barney off of the list, and then I can adjust his weight. Finding the biggest loser is calling collections.max. If you want to sort them, you can sort them now because you've got the compare to. And the other thing I wanted to show people was that when you call collections.min or max, basically min or max is just this little chunk of code, more or less. And so the way collections.min works is it goes out and it grabs the first person on the list as the current smallest it's seen so far. Then it goes through the number 1 through all of the remaining people on the list, retrieves them, and checks to see whether the next guy is smaller than the current smallest. And if it is, it says, oh, next guy must be the smallest. Okay? The trick there for a lot of people was this idea that this is how you do it in real life. And in real life, you don't keep the position of where you found the thing in the pile. You can keep the actual first loser that you find out of the pile to do the work instead. Okay? And so that's a very Java thing to do. Go grab the first one. It's a thing I'm now holding on to it. I can go through and I can find the rest of it. And I also said to a lot of people that this is the exception to Pfeiffer's rule about starting at 0. Okay? And the reason there's an exception is because since I grabbed the number 0 person off the list, I don't need to recheck them. I can start at the number 1 person instead. Okay? In general, if you see somebody who puts anything but 0 in there, then you should look up on the line above, a line or two above, and see whether or not they're actually processing the 0 guy somehow. If they're not, then it's a bug. So it's still sort of the same rule with a slight modification. Right? The intention is still to go through all of them. I just got the first one first. Okay? Another rule of loops is that you should never check for the first one with an if statement inside the loop. If you wanted to check to see if it was the first one, the best thing to do is get the first one outside, and then you don't have to check. And the same applies to the last one. There should never be an if statement inside a loop that checks for the last one, because you would always wait until you drop out of the loop and then find the last one and process it separately. So there's a couple of good rules for loops there. And finally, the fact that we used compare to here to compare one thing against the other means that the only way that sort and min and max are going to work is if there's a compare to available in your class to call, which is why we insist that people put up the flag that says implements comparable in order to make that work. And it's not okay to go out and grab the loser's weight, because if you're grabbing the loser's weight directly, you're doing too much. Because then you're making this loop assume something about specifics about losers. And you notice in this case, this loop doesn't care at all about losers. All that it cares is that they have a compare to, which means that you can take this exact piece of code and it will work anywhere, whether you're doing, losers or students or any other thing, as long as it has a compare to. So it becomes a generic piece of code, which is why collections.min can do exactly that. Okay? So resist the temptation to go grab something out of the object and do the work yourself. Just introduce the two objects to each other and let them decide. And whenever you run across a compare to, the shortcut for trying to understand what it does is to take that less than sign and plop it over top of that word. And so you end up with the next from list smaller than current smallest. Another common mistake in there was some people ended up with a greater than sign in there. And so if you invert this and you compare current smallest to next from list, you have to write it as greater than. But if you write it as greater than, you end up with this word saying smallest and greater than symbol, and you're going, well, one of them sounds like it's wrong. Okay? And so you want to make, in this case, that less than sign agrees with that name, and so it all makes sense. Okay, questions about the loser lab? Okay, losers are going away. Let's talk about the music player. We started writing a class for a music player. So one of the first things we wrote was the song class. I just fleshed it out a bit and added some the constructor and getters that I'm not sure it had the last time we looked. So I put those in. And then the next sneaky thing that we did was we started with this idea of let's make an interface. And an interface is really a standard or an excuse for somebody not to have to think about how to actually do the work. Okay? Take your pick. So what we've done here is we've said any music player that I happen to pick up off in the street, these are the sort of the standard things that I expect to be able to do with it. I expect to be able to somehow add a song to the player. I expect that there's something that allows me to say, let's start playing the next song. I can ask how many songs are on the thing, or I can go and retrieve some information about some song that happens to be on the list. Okay? So we came up with this idea of what the standard was for any music player, and then we turned around and we started to write one. And so the trick here is to say, I'm about to write a music player that takes care of doing whatever the standard says to do. And as soon as you add implements music player, then Eclipse will come along and say, well, if you're going to do the standard, you have to write these methods. And so it automatically fills in the methods for you, except they don't do anything particularly useful. Okay? So now we've got a standard music player, hopefully, that just happens to be broken. So what's the next good thing to do?
Fill it in.
Do what?
Fill it in.
Better thing to do.
Make a test.
Make a test. So before you even bother to try to see whether or not it's going to work, let's make a test. The test is going to do two things. It's going to A, set our expectations on how it should work, and B, it's going to work sort of like a main program where we can get the sense of what the thing is actually supposed to do. Okay? So we can start to use these methods and get a sense of how they work together somehow before we actually have to go write them. So there's nothing wrong with writing a test at this point. I'm going to write it against this thing. Eventually I'll move it over and call it music player test. But for now, let's just put the unit test there. So we'll see if or not we can test my iPod. We'll add a setup method. So let's start out by just seeing if we can make it do something. So this would be Daryl iPod. Make a new iPod. And it's complaining it doesn't like Daryl pod. That will drive me insane, but that's okay. Okay. So there's my iPod. I guess we might as well write a test for it. We'll call this constructor test. If the constructor doesn't work, not much else is going to work. How would you know whether or not iPod works? just for being set up.
It does those 5 things that we expect it to do.
If you get an empty iPod, what's the only question you can ask at this point? Size. So I think that if I ask my iPod the size should be exactly 0. So not much of a test, but at least it should start out empty. Let's try a better test. What's the next thing that you would want to do with your iPod after you get it? Put some songs on it. So let's do that. Let's try adding just one song. So we would make a new iPod. We would make a new song. And it really doesn't matter here what the name and title and all of that stuff is, because we're going to use the references to the actual song object to see whether or not it's in there. So we'll add the song. So there's the first song. Now what? Should be one song on the player. Anything else?
Make sure it's okay for
What song should it be?
Size of the song won't be less than the capacity of the iPod.
Go back and look at the music player. There's the things that you can say to the music player to find out whether or not it's working. Which one of those is going to help tell you whether or not if you added a song, it's actually working correctly? Size we just checked. So if you want to see if you add a song, the converse of add a song is really retrieve a song. So I guess we'll get the song back. So we'll talk to the player, retrieve the song, and then what's the assert statement going to look like? Got the current song, now what? What should it be?
Doing a search for my song on my pod dot current song equals AAAN.
Do you really have to check the name information, the data that's in the song?
No, you can just check. You can just compare them.
We've already got the ID number for that song. We're still holding on to it before the test, so we know exactly what it is. So at this point, you can check to see whether or not you get exactly the same song back. So the current song should be exactly whatever you put in, which was first song. Okay, so we're checking variable against variable there. Okay, there's no need to check the data inside the song to see whether or not it's correct. Well, if that was one song, let's try 2 songs. So we'll add a second song here. Change the name to add 2 songs. Even though I don't have to do this because they're separate news, I'm going to just make them look different in case I happen to be seeing them in the debugger. So there's a second song. I'll now add the second song. We already did the test to make sure it worked in the first case of adding the first song, so I'll just add them directly here right away. There's the second song. Size should be 2, and then what?
Search through current song equals first song plus second song.
Can't do a plus here. I have to check them one at a time.
For each.
Don't want to use a for loop in a unit test if I can help it.
Instead of second song, on my pod get song 1 and make sure.
So change this to a 1 and make sure it's second song.
Yeah, well, copy the test and do it this time.
So the better thing to do would be to retest to make sure they haven't done something silly with the number 0 song. The other song should be added to the end. So if we go and retrieve the other one, that should be second song. Okay, so there's a good test because it could have, when you got the second song, you could have placed it in the 0 position. You could have placed the second song in both the 0 position and the 1 position to just be silly. So the only way we know for sure is the first song had still better be where it used to be, and the second song had better be afterwards. Okay, so there's a couple of tests, and I still don't have a working iPod, but that's okay. I can turn around and I can still run the unit tests. And when we run the unit tests, they'll just mostly fail. Okay, so the constructor works, but add song and add 2 songs both fail. Not a particular surprise, because if you go and look in this class, it doesn't do anything yet, so it should fail. So let's go back to this iPod that we've got. What do you want to do to this thing to make it remember the songs? What kind of thing does it need to have inside of it? Make an array, or in the Java case, so far we'd call that a list instead. So let's make a list that can only hold songs, all of the songs on the player. And oh, look, we don't even have a constructor. So we'll put in a constructor. And it has to initialize the list. So make an array list that can only hold songs as a place to store all of the songs. Need to click on the bulb to the import of Java util, and the same for this one to get that import going. And now we've got songs on the list. Is there any reason why the music player interface didn't specify that we had to write a constructor? Did you notice that? We said that the interface was responsible for telling us all of the methods that we had to write. Why didn't it tell us how we had to write the constructor?
Because it doesn't know.
Sort of, kind of, it doesn't know, but what name would it choose if it was going to choose the name for a constructor? Bottom line is it can't know, because it doesn't know what I'm going to call my class that implements the interface. So if somebody else calls theirs Fred Music Player or Zen Music Player or whatever, every one of us is going to have a different name for our class that has a different constructor that starts up the music player. So the answer to that is the interface can't possibly know what the name of the class is that somebody's going to write that meets this standard. So it can't put that in there. So the constructor is just one of those features that you end up having to write yourself. Interface is never going to do it for you. Okay, so what happens when somebody comes along and tries to add a song? What would you like to do? Somebody hands over the song to the music player and says, here, deal with it.
The song in the next available position in the array.
Stuff it into the array, get the array to do the work. So that's all songs dot add whatever song they give us. Do you have to keep track of the number of songs that you've got? That's a trick question. You need to count the number of songs going into the all songs array?
Can you just reference it automatically based off of 0?
You can't pull the delta without anything in there, so that's so. You need to check the size before you add a song, make sure that you're not going.
Well, you can't go over the, so the array's supposedly infinite. So if somebody asked us for the size, how would you tell them how many items are on the in the player instead of 0? So the answer to the trick question is you don't have to keep track of it. The array is already keeping track of the number of items. So you can talk to the array and say, hey, how many items have you got? It will tell you. And then if you want, you can send that value back. Okay, so the whole reason for using that list is that it's going to hold on to things for us, and it has some utility functions. In this case, one of them is tell me how many items are there. You can shorten this if you want, and you can just say return allsongs.size if you don't care about the variable. But like I said, sometimes that variable is sort of useful just when you're running in the debugger to see the values of things. Okay, so suppose somebody says, get me song number 0. Talking to the music player here. Somebody says to the music player, get me song number 0. What does the music player do?
What's in the array?
Just ask the array to retrieve it. So let's go get the song out of the music or out of the array list. So there we go with talk to all songs dot get is the thing that retrieves by position. So we'll retrieve the thing and then we'll send back that song to whoever asks. How many unit tests do you think will pass? Well, now we've got the ability to actually store them and retrieve them, which is basically all the unit tests are doing. So we'll run the unit tests and yeehaw, the tests start to pass. Okay, so notice I wrote the test first and then I made the thing pass the tests. Okay, what other tests do you think we should add?
Skip the extract.
Let's take a look at what the music player can do for us. We've tested add song, we've tested size and get song, so the only things that we haven't tested now are whether or not we can play one. So we should write a test for seeing if we can play a song. I'm getting sort of tired of making all of this test data, but sure, I'll do it one more time. So we make my iPod, I've got a couple of songs on there. I've added the songs. I don't need to test for the size anymore. Now what? If I say my pod dot play next song, so that's basically punch the button to start it playing. What song should it be playing? First song, which is the number 0 song. How are we going to find out what song it's playing?
Looking current song.
So here's the standard so far, and the standard says those are the things you can do. What's missing from the standard?
Things you can't do.
Current song. I don't know which one's currently being played.
Don't know which one's being played right now. So this is like having one of those iPods without a display on it. You really can't tell what song is being played. So the problem, the thing that we're missing here is that most of these things have something where you can look at it and you can say basically get me the current song. Okay? So here's a problem with writing an interface. If you think this is as standard 1.0 for iPods, we sort of screwed up on the standard because we wrote a standard where we're missing some functionality in the thing. Oops. Okay? And so what we'd actually have to do if we'd already published this standard is go back to people and go, okay, here's the 1.1 revision of the standard. You all need to go say that you're going to do the 1.1 revision, and we need to add something that actually makes this thing work like it's supposed to. So this is a bad thing to do when you have to change the standard. It means you didn't really think it out through when you were trying to get the thing to work. But quite often the only way you find out is by actually starting to use it. Okay? So the functionality we've missed is it should be possible to say get current song. So we'll save that. And now notice what happens because the standard changed. Now this thing comes along and says, oh, you're not meeting the standard anymore. So we'll go in and get it to write the standard for us at the bottom. Hopefully there's get current song. Okay, so we fudged a bit and we changed the current standard. Okay, so get current song should return the current song. Sort of makes sense. What's the current song?
The ones currently playing.
Right at this moment, it would be 0, wouldn't it? Start at the beginning.
When you get your iPod,
We hit play the first song.
what happens before you hit play?
You put a song on there.
Hit power.
What's the current song on the display?
Nothing. Empty.
When you select it.
The menu.
Well, there's nothing, right? Typically, it doesn't, when you first turn it on, it doesn't start playing a song until you press play the first time. So conceivably, when you first start out with your iPod and turn it on, there is no current song. But we need some concept of current song. So we'll go back into the top of the class and we'll say private song current song. And now we have to set the current song variable. So I could set the variable to empty saying there is no current song. Do you think that's a good idea?
I would just say it's the first song.
That
It's the song
depends
after
if
you
it's
push
actually a song.
There might not be a song on the player to start with. So you can't set it to a song. If you have an empty player and you turn it on. So there's two choices here. What do they do for web pages now when you go to a web page empty. You notice what they've started to do instead of leaving the field empty?
Usually redirect people to spam page.
What do the googly sites do for the latest user interface? When you go to fill in a field.
Ask you to Google it.
No, when you go and fill in a Gmail for like a message or something, what do they do?
Make suggestions.
Let's just go back here and give one a try. Notice that to field? Oh, they don't do it in this version. Notice what they just did there? They pre-fill it with something, right? And notice that pre-filled thing is in very light colored text. So there's something there, right? It looks like the thing is, the field shows, they use the basically the input portion of the field to say, give you an idea of what the label is for the thing, right? So the old style web browser, the old style interface, what they would do is over here, they would have a label that said, enter a name, and a label that said, enter an address. In the new style thing, what they do is they write the label contents right inside there, and the instant you click on them, they change it to get rid of them. So they essentially make a fake thing that looks like stuff that you've already typed, but it isn't. Okay? The point is that there's actually something there in those fields that are sort of empty. Okay? Other than that it does a few bunch of other fancy things. Okay? So one of the tricks of the trade here is that maybe what we should do for current song is, rather than saying there's nothing there, we should fake it out to look like there is something there. Okay? Because the problem here is that if I make this thing null here, and somebody turns around and says, get current song, and it sends back a null, every time you have this null variable in your code, you have to write an if statement that says, oh, if it was not null, then I can do something, but if it was null, I have to do something else. Okay? Because you can't use the variable if it has a value of null. You can't reference it in any way to do something. Okay? See what I mean here? Let's go into the unit test for a second. If I were to write this unit test here to do something like this and say song current you'd have to write something that says if current is not equal to null, then we can print out the name. I'll just do a print statement here. We'll get the title. And I'll just use an else that I'm going to take away in a moment. Do something like this. Okay, see what just happened to my code? By allowing get current song to send back a null. Every time I call get current song, I have to do this check. Oh, okay, if it actually gave me something back, I guess there was a song that's the current song. Otherwise, I'm going to have to do something else to worry about, oh, there wasn't a current song, what do I say to them? Is there something better we could do?
A placeholder text.
Well, we can do better than just, this thing, null is a bad idea. How about this? Or if you want to actually see something visible, I can't remember whether that was artist to go artist and title or title and artist. Make sure I get song in the correct way. No, that's okay. Let's do both of them. Can't remember which one of those fields is title and which one's artist. Okay. Now look what happens in the test is whatever song I get now has a value. And so now you don't have to do that stuff anymore because you can just print out the title and you'll get something. Okay, so notice what happened to the code. Okay, if I send back a null, I got a problem. If I just send this thing back, it magically works. Now in the long run, I don't want that print statement in there, but I think it will actually print out someplace down there, although it doesn't really matter. Yeah, it didn't print out anyway, but that's okay. So what's our assert statement going to be now? Don't really care. Maybe I'll just skip it for a moment. If I play next song, now what should current song be?
First song?
Should be first song. Let's give that a try. And while we're at it, no, that was just one song. So let's just do that and see if it works. Oops, died. If you want to see what a unit test dies, you can go and look down here. And it says, I don't think current is actually first song. Why is it broken? It's a trick question. Our play next song doesn't actually do anything yet. We just wrote the unit test first. So now we'll go back and figure out, oh, what should play next song do? What song are you on now? When you press the play button. What song does it start out as?
Position 0.
The first song it's going to play is the position 0 one on the list, but what if the player is not initialized? Want to do this for a second? If I put in current song position, and I start out with my player, what should that number be? Zero would imply there's a
Shouldn't have any value, should it? Doesn't have a position on the array.
there is no position on the array because when you first started out there are no songs in play. So you can't say I have a current song of 0. So the best we can do at this point, if you want to use a position, is to say there is no valid position. So what happens when somebody says,
Was that a -1?
that was a -1. What happens now when somebody says play next song? What's the first thing that you're going to do? Increment 1 to say, oh, I need to go get the next current song position that I need is whatever the next one happens to be. If you want to retrieve it, talk to the list. Oops. Just so that we have those two variables in sync, keeping both its position and what it actually is. And so now when somebody says, get current song, you can send back the current song variable. This unit test will probably, if we're lucky, sort of pass now, even though we still got some things to worry about to make it broken. Okay? Just before we go, notice where we spent all of our squirming? The main issue with this thing is that startup case. Oh, I don't have a song playing yet, right? Oh, what do I do about the initial startup case when I don't have something but I really need more? Okay? And that's fairly typical of programming, is that we're going to have to deal with that in some weird manner. This isn't maybe the most elegant manner, but it does get the point across that what do we do when the display is empty thing is going to come up over and over again. It's no problem once we get something in there, right? Then it'll work. Okay? So it works now, but it's going to be a little flaky for the first ones until we fix that. But at least now we've got something that that tells us what the first song is when we press the play button. And with that, we're out of here for today.
Actually, our next class is in here.
Well, then I'm out of here for today.